Hello guys, welcome to my YouTube channel. Today we are going to discuss about fabrication in VLSI. Introductions to VLSI fabrications. VLSI stands for a very large scale integrations, which refers to the process of creating integrated circuit by combining thousands of transistors into a single chip. The fabrication process is crucial for ensuring the performance, reliability and efficiency of the VLSI circuit. Understanding the fundamentals of an VLSI fabrications is essential for advancement in an electronics and technology. Overview of an VLSI fabrication process. The VLSI fabrication process includes several key steps such as photolithography, etching and decompositions. Each step is critical for achieving the desired electrical characteristics and the physical layout of the integrated circuit. The proper executions of each stage significantly affects the yield and performance of a final product. The fabrication cycle is given here in the figure. We can see there. Design phase. The design phase involves creating a blueprint of an integrated circuit using specialized software tools. And the design process, where in this block diagram we can see that the design process will start with analyze the brief and identify the key requirements and doing a research about that topic or that problem, which is known as then idea generations, idea development, then productions, testing, implementations, evaluation and redesign. This is the phases involved in the design process. The engineer must consider the parameters like power consumption, speed and area efficiency during the design. The output of this phase is a layout that guides the subsequent fabrication steps. Photolithography. The photolithography is a technique used to transfer the circuit design onto the silicon wafer. The photolithographic process. The diagram of a photolithographic process is given here. Initially, we are considering that a photoresistant layer, then next to that which is known as a silicon dioxide, then silicon substrate. When the rays will fall on the photoresistance material, there is a formation of a positive and a negative material. If there is explorers of a positive, the diagram is shown below. This process involves an applying of a light sensitive photoresist material to the wafer and exposing it to an ultraviolet rays, and the export areas then developed to create a pattern that will define the structures on the chip. Etching is a process of removing specific layers of a material to create desired features on a wafer, and this can be done using wet etching, which uses chemical solutions, dry etching, which uses plasma, where the steps involved in etchings are given in the figure, which is known as the first step, which is known as lamination, second one is exposure, and the third one is developing, fourth one is etching, fifth one is stripping. So the choice of etching method can influence the precision and the quality of final features. Ion implantations. Ion implantation is a technique used to introduce impurities into a silicon wafer to alter its electric property. And the process allows the precise control of doping levels, which is critical for creating a p-type and n-type semiconductors. The ion implantations figure diagram is given there, and the placement of ions can significantly affect the device performance and characteristics. Next one is a decomposition technique. Decomposition is a process of adding thin films of a material onto the wafer surface. The common decomposition technique include chemical wafer decompositions and physical wafer decompositions. The quality and uniformity of thin films are essential for effective device operations. The chemical wafer decompositions. The chemical wafer decomposition is commonly called as a CVD. It is a used technique for decomposing thin film material such as silicon dioxide or silicon nitrate. For chemical vapor decomposition, we are using two materials which is known as silicon dioxide and a silicon nitrate. This process involves chemical reactions that occurs in a gas phase, leading to the decomposition of a solid material on the substrate. CVD is favored for its ability to create high quality films with an excellent conformality. The diagram of a CED and a procedure of a CED is given here. Initially the initiator is given, then the flow controls control the decompositions, then it gives to a vacuum chamber. From vacuum chamber it is the exhausted gases will come out. Physical vapor decomposition. The PVD. It is a method that involves a physical transfer of a material from a solid source to a substrate. The techniques such as superating and evaporations are commonly used in a PVD process. The PVD is a noun for producing high purity films and is often used for a metal decomposition. Annealing. Annealing is a thermal process is employed to repair the damage caused during an ion implantations. This step also helps attractive dopants, enhancing the electrical properties of a semiconductor. The proper annealing can improve the overall performance and reliability of the fabricated devices. Chemical mechanical polarizations. CMP is a critical process used to achieve a flat and smooth surface on the water. This technique combines chemical and mechanical actions to remove the excess material and polarize the surface. The well polarized surface is essential for the subsequent lithograph, and that steps ensures that an accurate pattern transfer. The diagram is given here. Initially, the wafer ring, the pressure is applied to a wafer ring, then the clary, then the polishing pad and a polishing platen and a conditioner slurry. These are the components used in a chemical mechanical polarization. Packaging. Packaging involves enclosing a die in a protective case to ensure the functionality and durability. It also provides necessary electrical connections to the external environment, and effective packaging is vital for thermal management and signal integrity in VLSI devices. Testing and validations. After fabrication, the extensive testing is conducted to validate the performance of an integrated circuit. The testing methods can include functional testing, parametric testing, and reliability testing. The successful validations ensures that a device meets a specified design criteria and performance standard. Yield management. Yield management refers to the process involved in maximizing the number of functional chips produced from a wafer. And the factors such as defects, process variations, and equipment performance significantly influence the yield levels. The continuous improvement and monitoring are essential for optimizing the yield in VLSI fabrications. The wafer yield management semiconductor manufacturing is given here. It has mainly 4 types: ramping all the semiconductor manufacturing process, tracking all the yield result, automated tracking of test result, and real-time detections and resolution of an yield issue. Challenges in VLSI fabrications. VLSI fabrication faces several challenges, including scaling limitations, material defects, and also cost pressures. As the technology advances, the maintenance curve compatibility with an older process while implementing a new technique is complex. Addressing all the challenges is crucial for the future semiconductor manufacturing. The future trends in VLSI fabrications, which is known as the VLSI fabrication is moving towards smaller nodes and 3D integrations technology. Innovations such as extreme ultraviolet lithography are enabling the productions of smaller features. The enhanced materials techniques are being developed to improve the performance and reduce the power consumptions.